Okay, so this is started. So the target for today is, let me share something to have the end-to-end project actually. So on the core Kafka side or stream or connect side also, we have learned things in bits and pieces a lot in service setup also. So if we have to apply all that in a project, so how that will look like. So that's the idea for today. Let me see the stories that I have. Okay, something is wrong on the medium, I think today. It's saying that untitled. It is not able to load things. I have to watch every.
Something went wrong.
I think medium side is down somehow. Yeah, you see, it's not working. Anyone else can try on their system?
Yeah, yeah, yeah.
It's same, no? Okay. Anyway, we are not entirely dependent on
Yeah,
this.
working.
It's
Library.
it's working.
Yeah.
Mm, Let me see.
Refresh our home page. Then
Disconnect, reset before the disconnect. Okay. Anyway, I'll not do this one. So basically, end-to-end project that I want to explain. Like, what are the things? I think one or the other way we have seen in the individual services, but how the things should look like. Basically, let's say here we are going to have a client and there is going to be a order service that we have. Respectively, there is a going to be having a this is order database also. This is where in here we are going to have a Kafka Connect with this one. Outbox event is going to be there. Let me know if during the explanation itself it is not making sense, because this is what we will be implementing the next step that I'll be showing. So Kafka Connect, and that is a Debezium specifically. It will be coming in into the picture and sending the events to the orders topic directly in here. From that orders topic, there is going to be a payment service that is going to be listening to this one, and this will have its own database in here now. So the reason for the order service connecting this way, the database and Kafka connect this one, because this is the tier 1 service that we are calling. And we want to offload as much dependency as much possible. So we are not making a direct dependency of the Kafka, that if Kafka is down, the order becomes Kafka becomes the reason for the order failure entirely. But for the payment and other things, because they are already in the async way, we don't have to do that complex setup itself. So orders payment service is consuming from the orders topic in here. It is storing the data or record in its own database, because these are entirely different services running, right? And further, this is publishing the topics to the payments topic. So this is where this service has integration with the payment gateway or payment related anything that's needed, that is happening in here. If it is completed or failed, accordingly, it is going to send an event into the payments topic. Okay, so payments topic is going to be consumed by the further in the chain, that is the inventory service. Inventory service also going to be have its own database in here. It is going to store the information, check the records. If the inventory is available, it is going to update that. If it is if there is any, so there are two flows are going to be happening. Payment, it is going to put the events in the payments for the inventory to process that one. Okay, but at the same time, we need the order status correctly to be updated in the order service itself. So it will be sending that order, basically this payments one. So payment success, payments failed or anything, it is going to come. So payment service is associated with the payments topic only. And inventory, similarly, it is going to be associated with the inventory topic in here. It is going to put the informations in here. Whether success or failure, it is going to be available in here. Inventory topic is going to be consumed by the shipping service. This is going to process that whatever data is available. Happy path, if talk about those, so the inventory will be deducted properly, that event will come here, that inventory is there, so shipping needs to be processing. Shipping, it's going to be having its own databases. It will make its own third party call if it is it is going to hand over by the taken care by the third party, so that all that will be taken care in here. But the order is status will be updated, that shipping label is created, and it is going to do the rest of the jobs there. So here, whatever state we are going to be having, so that order state is going to be created. Basically, here it is a created, here payment done, here inventory reserved, that is the status, or inventory failed, whatever is there, shipping done, this is going to shipping created, basically it is going to be there. And when after that, shipping events will be published there. So shipping in progress, shipping completed, order delivered, so final status will be the order delivered actually. All of that we are having in here. So there is this notification service, right, that needs to notify for each and every state that is it is doing. So it will be capturing, or it will be consuming on each of the topic that's there. So it will be listening to the orders topic also in here. It will be listening to the inventory topic also, and this one also. All of that. So orders topic, payments topic, inventory topic, and the final one is going to be the shipping one. Shipping event will be created. So this will be listened by this one also. So all of that notifications will be sent to the consumer. Your order is created, payment is done, inventory is reserved. And this is the notification side. It's that system design that we do not want to bombard the user with so many of the events. So this is the notification service side. It can collate a couple of events, like if they are coming within 1 minute, so it can like aggregate those events and send those messages all together, that what is the final status, instead of sending one by one. But if they are taking time, so it can keep updating the user that what is happening with that record. So this is the setup that is going to be having. So we are going to order service database in here, in there Kafka Connect Debezium is going to be there. And all of that, whatever event is going to be occurring in here, we want to be having the APM in place. APM, we have multiple options. We have Grafana, right? We have Newrelic, we have Dynatrace and Datadog. There are so many. Integration is quite easy, but yeah, we can do that one. The end-to-end tracing will be easy, basically. So let's say order got created in here. It will be getting an order ID, right? So that order ID will be passed on up to the end, whatever logging is happening. So if we have to track that, so we can go to that APM platform, search with that ID, we will be able to see where that record is actually. So if someone is reporting there is an issue, or we are not able to see that final state in here, we have to see where that is stuck, where that event is stuck actually. So this ID is going to help us, and that new this platform is going to help us in here. We will be able to see where it is actually. Any questions so far? Okay, I'll take that as all good. So for this one, we are going to use the Newrelic in here. Okay, for the integration. So let me show you the first service. So all of that services are there. I will walk you through the code and everything that is available there. So if I show you the entire plan in here, so under the implementation directories, I'll change this one. In the GitHub also, you are seeing in this in the same flow that's there. So here, let me open this in IntelliJ itself. Yeah, this one. This will give a nice view. So this has all the folders and everything that is needed. So very first thing is the infrastructure setup. That is the Docker Compose YAML. In here, all the infrastructure is there. Like first thing is that Apache Kafka, it's there. The second one is that we need the database for each and every service. So the Docker can help us to create the database within the container itself. So for the, it is the same MySQL 8.0 version, but for the order, it is creating its own boundary, like running on the 3306 port because we have only one machine. So we will be changing this port. Payment database, it is downloading the same thing, but it is running on the 3307 in here. Inventory DB 3308. That's how we will be connecting outside of the Docker network in here. Shipping DB 3309. It is connecting to this one. Notification DB 3310. So all of that has its own database in here. Finally, we have Kafka Connect, which is Debezium Connect. This is downloading this one and it is running on the 8083. This is where we will be connecting MySQL connector, that Outbox table in here, and the event will be published. And
Hey, Arvind,
finally,
sorry to interrupt you. One question. So this Kafka, this Docker, every service has their own file, right? So you are creating one file for all the services,
so
like.
it is the not the service one. For the service, there will be different Docker file available so that it can run that one. But it is about the infrastructure setup.
So the database also it will be part of this individual one, right? So that way it will be correlated together, right? I want to understand the idea. That's why I'm asking it.
Yeah, yeah, that's correct. I think
Yeah.
in the real system itself, if you see the database infrastructure setup is not tied to the service itself. Uh, in the real infrastructure setup, right? So the database setup and everything is a separate process. It's independent from the service itself. Because if
Okay.
you put the that Docker or anything file in the service itself, if anything happens with the order service, that database also goes down, right?
Mm. Okay.
Correct. So essentially in here for the local one, local setup and local development purpose, we are putting the MySQL and everything in as part of the Docker compose and running everything in here. In the real time stuff that we have, there is a different machines. Maybe those are set up and those are executed that way in here, in
Oh,
there.
okay, fine. Okay, thank you. Go ahead. Sorry to interrupt. Go ahead.
Yeah, no issues at all. But it's fine to get an idea, like the complete picture how it is working. You see, in the real-time system, when these services are deployed on the cloud, so those containers goes up and down all the time. So the database is running as a separate service or it is running on a separate EC2 instance there. And we get the local host, like we get the host and port there to connect to that one. The database infrastructure is never part of the service itself.
Oh, okay. Okay, got it. Thank you.
So that is why I have created it separately so that it's working independent of that one. So because locally we have to do some sort of these things. So those databases, Kafka Connect, and this one, and finally Kafka Drop. It's created in here. So if we start this one, all of that infrastructure will be ready in here. That's what I have done in here. Like the to run this command, it's very straightforward. Docker compose up, we just have to be in that same directory where that docker compose file is there, and the command is this one, docker compose up -d. So whatever services that we have, it is first time it is you are running this one in your system, you will see it will take time because it needs to download everything from the internet. But once it is there, it will run smoothly there. So all of that is running. Kafka Drop, Kafka Connect, it is running. So the very next part is the order service itself. We have to start the order service so that we are able to create the orders. Let me just stop everything in here under the build.gradle. If I show you the initial dependencies that we used to have, it is going to have the same thing, starter web. Okay, it is going to have a starter web. Like 401, this we can have the web, not an issue, but web MVC is there. I'll make this change in here, data JP and everything. So probably similar things are there that we used to have in the previous projects that we were doing. Time leaf is there because I wanted to have a front end interface to create the orders there. That's it. Then coming to the main files that are there. So configuration, we have Kafka configuration in here. Order service, why it is having a Kafka configuration? Because it is not directly tied to the Kafka. It should not be, right? So the thing here is that it is not tied as a producer of the event itself, but it is tied as a consumer of the event. Because I say initially when that order is getting created in here, right? So that status is that order created in here. What about the rest of the status, like payment is updated, inventory is updated, shipping is updated? Those status needs to be updated. So I have set up the order service as a consumer also for the payment, inventory, and shipping, so that all the statuses it is consuming that one. So whatever you see, it is going to have that setup in here. Producer is there because it needs to handle the DLT. Like if there is anything wrong, it needs to send the data to the DLT also. But the primary thing is in here is the consumer factory in here that's there. And the transactional setup is there. That is why it is mentioned that read committed. Couple of configuration I'll talk about. So ID, group ID, it is going to be there. Deserializer, going with the string deserializer itself in here, not the JSON one, just to avoid the complexity. False, auto commit, it is false. It is committing the offsets manually, and it is doing the reset configuration earlier so that it can read all the records that are available, whether it is up or down. And the read committed, it's about the transactionality. When that record is committed from the transactional producer, only then it will be able to read that. And this is the max pool records, and these are the session timeouts and other stuffs. Consumer configuration, these are the similar ones that we have learned from the previous sessions in here. So just the important thing is just to read through it. Controller, order controller, one is the REST endpoint in here. The create order that's available, it is going to take the request, it is going to create the record in here. So the REST endpoint is also available, but the web controller is the one that we will be using. That is going to be there via time leaf available. So if you see the get mapping, and this is the post mapping, this is the order that it is going to do. Create order, it is going to take the create order request, and rest of the things it is going to do the same thing. Transactional, creating the order, total amount and everything, and it is going to order items, it is going to save that order, and at the same time it is going to create a outbox record from there, and it is going to save that into the outbox repository. So that's the job of this one. Others are the helper one for this one basically. So web controller is the one. For the consumer part in here, if you see before consumer, we can see the repository, order repository, and outbox repository are there. So this is straightforward. And service, we have order service in here that takes care of the connection with the order repository, and if there is any validation and things that we have to take care. And then we have what else? We have product management controller also. I'll come to this one because it needs to get the products also so that it can show on the UI itself. Let me just start this service and show you the front end, then it will make more sense, the connections that we needed. Okay, this is, you wait here. This is actually already running in here from the, to run this command is straightforward, gradle clean build, that boot run, that's already running in here. So I can take you to the this thing. So this is the front end that we will be getting in here. So initially the thing is that these orders you will not be seeing freshly if you're acting on this one, but rest of the things will be there. So if I have to go, so how we navigate this one, go to the place order in here, and we have to just give the customer ID that we want, the product ID that we need, and the quantity that we need in here, and the amount. And if we have to add the multiple orders in here, that we can add sample product that is adding, and this is what we can do that. And the shipping address, we have to mention anything. So the realistic thing that's there, as much as possible, I tried to do that one because the product catalog and everything is not there. So in In this one, if you see this architecture in here, because inventory service, that is the one. If I have created a order for, let's say, iPhone, that iPhone needs to be available in the inventory. Otherwise, it is going to fail that, because it will check the inventory. If it is available, only then it will pass that one. Otherwise, it is going to reject that one. So that is where that order service connection is needed with the inventory. Inventory is acting as a consumer, as well as it is working as a REST controller also, so that we can get the record of the products, how many they are available there. That is where we have this endpoint, like manage products. So here we are not seeing any records, but because I have not started the inventory service yet. So if I have to add the product, anything in here, so we will be able to add in here, and the same order we can place it in here. So that's where the end-to-end success will happen. Otherwise, it is going to fail on the inventory side there. So if I do this for, let's say, unique customer 61, and let's see, give this 123 and place the order. So I got this order ID in here, and here we are seeing the order status is in here. From where this is getting the record in here, this is getting the entry from the orders DB itself that we have. So order items, orders, it is reading from here only. So we have each and every record persisted, so nothing to worry about. So status is their payment completed, pending. So now this status will keep changing as the event is processing. Otherwise, it will be continuing on the same itself in here. So the pending is in here because the payment is pending in here. That event is not processed yet. So this is the order service, and that is where the connection with the inventory, this product management controller that you see, this is the making a call to the inventory service in here. So this is the REST template call, nothing fancy. It had just those like to get the records. It has the get mapping listing all the products that are available there, and it has functionality to add the product also. Any questions so far into this one, the service setup basically? Okay, so the final piece is in here, that the order event consumer that we needed. So we have all the topics as a consumer in here, like list order service listening to that one. So the payments, to update the payments status, if you see the implementation of this one, it is just taking that record in here. Event type will be there with all the events that's there. So it is going to check the event type. It is the, if it this is the processed one, that is the successfully updating, so it is going to update that status payment completed. If it is failed, it is going to update that payment failed. So it is just for that status update, so that anyone coming to check the order status, they get the current status that's there. That's it. Same thing is on the inventory side also. Inventory side, two things can happen there also, that can be reserved. Inventory is reserved or inventory is failed. Shipping, there can be two things happening, like shipping arranged in here, or shipping label created. So multiple things will be happening in here. So here, this is where we will be waiting more on the current status that's there, right? So shipping is created, the delivery person is out for the delivery, so it can take 2-3 days of time. So that is where, when they update the status regularly, these things will be updated. But for now, this is because we want to complete this process, so we have just completed, assuming that everything is completed there in here. So shipping arranged and shipping completed, this status got updated immediately in here. If it is failed any point in time, so that failed status will be there in the order service itself. So this is the job of the order event consumer that it is doing. But even if the Kafka is down, so order service, actual order processing will not fail. When that Kafka is coming up, the event processing will start processing that one. So these are the definitions of the all of the things that's there, and this is I do not see these are the new things, because in all the sessions that we have, we are seeing the order service itself in this way. So what is new in this one? So the new thing is that that we have that I was talking about, the Newrelic integration, how we can do that. So that integration is completed in here, that I already have done. So how do we do that? It's very straightforward. Every APM that's there, they work on a agent ecosystem, right? So when we run our application, we are running them via a artifact, right? So Java -jar, and then we mention the app.jar, like our service.jar. So these APM providers says that they provide a agent basically. Agent, what they does, so if you can attach this agent where with your JVM when you are starting your application, so whatever events, whatever things like logs, metrics, GC, or any sort of thing that is happening around our application, these agent will be forwarding to these systems. So Grafana has its own agent, Newrelic has its own agent, Dynatrace has its own agent ecosystem. So we do not have to make any of the change in the code that's there. But when we have this artifact created, let's say order service is there. So when I create Gradle clean build, so that artifact will be ready. Whenever we are running that, starting that service, we just have to attach this agent in there. How do we do that? There is a very nice way in here. So let me open the incognito mode just so that things are scratch. So for this one, you just have to log in here. At the very generous free tier is available, so nothing to pay in here. So if you log in this one, there will be set of steps in here. So let me take you back in here itself. So Newrelic itself. Okay, these are the things that are already there. So integration and agent. So this is where we have to come, and here look for the Java, and how do we want to instrument it in our application. This is the step-by-step process that can be done with any of the application that's there. So whatever configuration that we have to choose that. We have Maven, we have host, we have Gradle, Docker, what we want to instrument it. In our case, it is a Gradle. So I'll choose this one. So this is where we have to mention the license key and your user key. We can create the new one, or we can create, like if we do not have the key, we can create that one. But if it is already available, we want to use that one, we can do that. So we can say, let's say, use the existing key. I'll show you the key that is with me, but later on I'm going to remove that because these are the sensitive informations. No one should share this. So let me see Newrelic. So these are the things that will be, if I create on the new key, so one new key will be created, but there is this already with me, the license key basically. So I'll create the existing license key that's there. Okay. And user key is also there. So user key is this one. In my case, I will use this one. I will continue. What is the setup that I'm using in here? That is the Linux. So the next step are there. Java version needs to be there. OpenJDK, we can check this one. Java is the primary information that we need. So what is the framework that is needed? We have a Spring Boot, right? So we choose this one, the continue. And these are the things that it is asking us to add in the build.gradle in here. So we just have to add that. So in the order service, it is already there, and order and payment service already integrated. So inventory service is not there yet. So let me do this exercise in here so that we can see this is happening. So this is the plugin information that just have to. Okay, I will just copy this to clipboard in here and go to in here. And this plugin section that I have to mention in the Gradle case in here and have to remove from here. This inventory service is also similar to the order service. It's just that it is a consumer and listening from the payment service, and it is forwarding that event to the inventory topic there. So we have these two things there. So one of that thing, it is just saying that it is deprecated. Maybe Newrelic is not updated with that. So tasks.register, we can just see that cross will be removed from here. If it is done, so it is also saying that what is the command that we have to run in here. So Gradle download Newrelic, and it is the unzip command that it is going to give us in here. So just refresh this and this. So it is just going to download that Newrelic artifact for us. After that, we just have to name our application. In the meantime, inventory service. This is the one. And this is done. Then we have to mention this file in here, newrelic.yaml, that's there, right? So here, nothing to change. We just have to copy this, and here it has mentioned that where we need to put it also, Newrelic and Newrelic YAML. So this one of the folder it already created while downloading this one. So we have that folder available. So we just have, okay, it created that newrelic.yaml file also. So in here, we have to mention this thing only. Whatever is we just got from here, right? So we just mentioned in here, the license key and everything it copied. We don't have to change anything. Isn't enabled. Just leave it from here. It will take care of the things. So when we did this, this command, it downloaded and unzipped that one. So we have this newrelic.jar. That is the thing that we needed. So let's see what is the next step. So this is saying that this is the command that you have to run now. Java-java is in, and full path to newrelic.jar, and this one. So let's see. With this one, I do not have that available. So what I will do, so that artifact is created for me. Okay, so with this, we have with this and this this library got created. So now just I have to run that command in here, whatever is there, Java isn't in here, and then the path to this one. Because I am this inventory service repository in here. So the path to this one is the Newrelic and newrelic.jar. So this just make sure that this path is correct. After that, -jar, and then location of that artifact inventory service that we have. So that is available in the build. Under that we have libs. Under that we have this. You see, we have two files in here. So we just have to mention the snapshot one, not the plain one, the fat jar. This is the thing, and we just have to make sure that license key and is there. Nothing is edited out of this one, and just hit this. With this, these logs are going to come in here. I do not see anything wrong, and this is that service is going to be running, and it is going to print the logs that it is doing. It is working as a Kafka consumer in here, so we are already aware of this one. It is just printing that those Kafka configurations in here, and nothing as a business happening in here. So just coming down. Okay, because you see some of the things that we are seeing, inventory service and all, it is doing that now, because those events were already available in that payments topic, and it just processed those things. So what am I expecting that? So because that Newrelic is now integrated in here, we should see that in here. So just see this continue, and these are things that are optional. I will skip this one. I will skip this one also, and this test connection, and we'll see that is status successful. That means this is there. How do I see that service in here? So see the APM and services in here. See the inventory services live in here. Order and payment was set up in the same way. If you open this inventory service, we will be able to see everything, all the metrics, RPM, throughput, logs, and everything. Abdex, transaction time, throughput, errors, transactions, and all. The important thing for us is in here, that is logs. You see, we got all the logs in here, the order ID and everything in here. So the important thing is in here that the tracing part that I was telling, like if we have the tracing enabled in all the services, because the recently I did not create any order. Some of the orders were created previously, but the inventory was not processed there. So if I come in here e-commerce, so some of the statuses I should see changed. Inventory result for this one. For this one, payment itself is not completed, but for this order, that inventory got reserved now. And this is the order ID. So if I have to see what all happened with this one, so in the Newrelic itself, there is I was here, right? So yeah, at this place in here. In the Newrelic itself, there is a log available at the service label and one available at the global label on the right side. That aggregates the logs from all the services that we have. So far we have instrumented payment service, order service, and inventory service. So we should be able to see all of that in here. So just mention that order ID, it just search the text in here and we are able to see all of that. We can see the entity.name so that we can see the name also in here. Yeah. Entity name. So you see all of that, whatever is originated from the order service for this order. So outbox event written for this order, order saved, received, from after order service, there is a payment service in picture in here, then processing the payment. All of this thing is happening in the payment service. All these logs are there. Then again, we have that order service consumer listening to that payments status check. Then right, so you see the timing also, right? So this is UTC time actually. That is what we see, that 14:45 in here. But after that, this inventory got updated just now. So we are seeing in here that that's available. Order after inventory, order service updated that order status correctly in here. Inventory got reserved now. Any questions so far that we have?
Arvind, just go to the diagram. I might have missed something, so I want to check diagram.
In this one?
Can you go up? So this order service and the Kafka Connect. Can you explain a little bit on this three part? Yeah. So what's happening here?
Yeah, correct. So this is the order service that we have.
Okay.
Order service is the entry point for us to interact basically. So as a we are going in here, we are creating the order.
Okay.
Order service, it's saving the record in the database as a order table in here. At the same time, it is making an entry into the Outbox table. This
why it was doing that?
Yeah, so that is where we need to connect the Kafka Connect Debezium. Okay, so because this Kafka Connect Debezium, in this table, so this is important actually to understand, there is two tables available in here. The order table itself and another one is the outbox basically. So order table is going to be having the source of truth, you can say, for that order created, and after that there are status updates going to be happening. A lot of thing is happening around the orders. So we have a control, but all of that we do not want to pass to the Kafka topic. That is the reason that we created the Outbox table separately. And that Outbox, we will be doing the cleanup also for the older events there, because the way that Kafka Connect and Debezium, because it is listening to that CDC events in here, right? So polling to that one, basically the bin log information that's there, it is going to capture that one. So whatever insert, update, anything is happening around that one, it is going to capture and going to put that into the further topic. If
Okay.
you do that in the order, that control will be very limited actually. Then if we have Outbox table, we have that control in here. We can decide what things we want to update in here. Today there's an order, tomorrow it can be some other table also that we want to put in the Outbox, we can do that.
Say, if I understand correctly, if say for a particular order, maybe in order table might have a 5 entries. In the outbox table, it will get the latest of one record for that particular order ID. Is that
uh, for particular order ID, not, I do
okay?
not say that 5 rows, but you can say the same order ID might be getting the 5 updates, 5 update calls on that record, but Outbox will be having only one update. Let me show you
Okay.
here. Let me show you this. So you see this order DB itself, we have this orders record, right?
Okay.
That has 4 entries in here. So let me, the same number of entries will be there in the Outbox events also. But the thing is about, what I missed. Okay, so here we have this 4 records, right? And in here also we had 4 records. So the difference in here is that you see the status getting updated. We have created at and updated at in here. So it got created at 14 Jan and this time, and it last updated 1643 in here. But for the same order ID, just 88411, if I see 8841, this one, right? So if you see the created at, this is the one that got inserted. This is the same time. The order got inserted and this got inserted in here with the payload, whatever information is available in here. But later on, whatever status update is happening, that is not happening in the Outbox events, because we do not want that to be happening.
Okay.
Right? And later on, if we have huge number of records processing, because these events maybe after 1 week or 30 days, we can set up the cleanup of that record so that older records gets cleaned up automatically in the Outbox event. Because once they are processed, these are the transient records, right? We do not need them permanently.
Okay. Okay. Thanks.
These are the few reasons that we separated this in here. So Kafka Connect listening to that one, and it is sending to that orders topic. Payment service is listening to that orders topic with the consumer configuration, transactional consumer and producer configuration. So the payment has the consumer, it has retry configuration there, it has DLT configuration there. So that is why you see in our Kafka Kaf drop in here by now, because we set up the Kafka Connect and all, it got created in here. And let's say I type orders in here. So respective to orders, order DLT got created. Retry, payments retry got created in here. So some of these topics, when those events are happening, they are getting created automatically when they are happening. Inventory got created. Shipping, only shipping got created because order is consuming on this one. But when we start the shipping service, that will also start there. Okay. So I hope the thing is clear now. Na? Now the chain is same, like orders, payment, shipping, inventory, shipping in here. All right. Any other question? Because the thing that I want everyone to understand in this one is the flow that we have entirely in here and how this is connecting to the Newrelic. And we are able to aggregate the records in here, aggregate the logs and see things end to end. Individual service setup is not the new thing. Kafka configuration producer retry. This is the same thing that we have been doing so far. So even if I have completed up to this status that's there, you see the inventory result in here. I'll start the shipping service. Shipping will be processed and it will be successful in here. And we can simulate the failed event also. We will see the failure in here also. Right. So if we can now go to the shipping service inventory. Position open. Projects, GitHub, this one. Shipping service in here. Okay. So this one, because I was trying this out on Office system and I needed to take that project from there. So some of the settings get problematic. So 17, I do not, I need 25, apply this one. And so for this one, let me just start this service, not attach the Newrelic in here. Okay, let's see how easy it is to do that one actually, even if I have to do that. So clean build is ready, right? So I have done this one. So the next what I have to do from one of the previous services that is there, this Newrelic is there, right? So I already have set it up. So I just copy it from here and paste it in here. Do not ask again, cancel. This is available in here, R file. This is there in here under Newrelic. So what I need to change in here, just the name of the project. So license key and everything is going to be the same. From the payment service, I just have to Control C, Control F, Control R, and Control B. This is the shipping service. Right. So I will replace all. That is how Newrelic YAML is ready for us. Like the shipping service, license key and everything remains the same. To attach this there, I just have to attach that agent. And where is that agent? That agent is this Newrelic jar only. So Java hyphen Java agent this and that path Newrelic dot jar and then hyphen jar. Then we have build, we have libs, we have dot jar in here. If I start this one, you see the shipping service is not listed in here yet. This will come after this. Is include Newrelic. Okay, I did this mistake. So anything wrong, it should be jar, not Java.
Arvind, so till it was loading one question. So in real-time production, so this Newrelic YAML file, everything will be given by DevOps team or whoever setting up that thing that we need to add, or how it will be happen in real time?
Yeah, real time. These things will be given by the DevOps team itself. So these are the repetitive setups. So yeah, they are available from them.
So repetitive statement as part of the project creation itself, you create this folder, you create this YAML without going to them because of existing entries there. You just add like that, or how it will be.
Okay, just give me 2 minutes. I'll come to this one. How in the enterprise system, because you see the repetitive things we are doing in all of the services now. So in the enterprise, we do not want, and we need to maintain a consistency also. And every developer doesn't need to do these things on their own. So just give me 2 minutes. I'll just show you this inventory. Okay, this shipping service also got in here. So we can just see that. Let me see that order got updated in here. So what is the new status? You see, after that inventory got reserved there, shipping got created, and I explained you that we have that shipping label got created in here directly. So let me, in the shipping consumer side, consumer shipping event consumer, right? So it is listening from the previous topic, that's inventory in here, and it is based on the event type that it has. The validation sort of thing is there. Processing, label creation completed in here. So this is creating the label created, creating shipping label. So idempotency check is also there in here. So it is doing that so that it is not processing that again. Shipping address and everything it is doing, and then it is saving that. Shipment ID. I'm just trying to see that. Create shipment label, and where we have repository. Yeah, this is the event that it is creating somewhere, right? So Kafka template dot shipping topic, it got created, that label created, and this got processed by the order service to update that status. So that is where we have end-to-end things are working. If I show you the global logs, this was the one, right? Order status updated, inventory we have seen so far in here. So the new entry got created, new status got completed, shipping arrived, and everything in here. So we have one happy path ready up to the shipping. So the notification is the last one. I think that's obvious. We can create the notification service and it will process from there. But I can explain that part, that we have, like how it works in the enterprise system that we have. So that is where, because we have repetitive things for the infrastructure or some sort of similar things there. This Newrelic or any other agent that's there. So that is where, when in the enterprise, any new requirement or any new service we have to create, we do not have to create that from scratch. What I mean by scratch, we don't have to go to the start.spring.io, take the dependency and create that one. There are standards built there. Those standards can be in two forms. The most popular that I have seen is like create a template, service template basically. So that template can be, this itself is a boot service. That means a Spring Boot service. This is going to have some specific setups. Let's say all of the services that we are creating, they need to have a specific dependency. Like let's say this is need to be have a web. Those need to have a Kafka, because their Kafka services are there. Some sort of security services are also needs to be there. So all of that service will be, all of that is available in the template. So if any new service, we have to create it from there, and all the configuration, like when that service is ready, we have a logging configuration, like how do we want to, I think I missed to show one more thing in here. So if you see the structured logging that we have to create, I think this is, I missed to add in here, but if you see the payment service in here, service resources, log back Spring configuration. We want a structured format of the log to be pushed to the Newrelic, not in some random format actually. So whatever we have default configuration, that is how we override that, the info or want, whatever logs. These are the standard ways that the Spring Boot reads automatically, and it does that there, that what informations that we need. So this information, application YAML had certain configuration like server port, application name, GitHub informations and all that. All that configuration, logging and everything will be part of the template. So if any new service is coming in here, so we just have to fork it from there. So we fork it from there. So let's say this is the template and we have to create the order service there. So we fork it from there. We rename couple of things that is specific to our service. Like we have to name that to the order service. So order service is going to be renamed that one that way. and everything else will remain the same. Very minimal things we have to change. All of the things remains the consistent throughout the enterprise. All the services are following that. And if there is any change, any new standard or anything coming into picture, that will change happen in the template itself. All the downstream services, if you see in the GitHub itself, that terminology is same across system, actually nothing new in this year. So if you see, there is a system of the fork in here, right? So if anyone forks from this repository, I'll be, so this create fork, if I do this one, that will be linked to the parent one. This is the GitHub normal thing. So that will be linked to there. So if any update happens in the parent directory, we will be able to pull that information. So that is how the consistency is maintained across the organization. So let's say in the Newrelic YAML, we want to make any change like tracing or AI enable, any feature we want to enable it. That gets updated in this template, and rest of the services just they are getting the update from the upstream. That will not happen automatically. It's the manual one that they have to update from the upstream, but there is a like one source of truth that they have to be there. I think this.
Yeah, okay, but yeah, I got it. This is the way we do also. Just
Yeah.
want to check because you showed me in the screen where you are entering everything, then you're creating YAML. So that's why I asked. Thanks. Yeah.
Yeah. So I think that is what I wanted to spot also. Like, see the copy paste we are doing, if there is any better way to do that one. So yeah, this is, I think, enterprise wise, this is how it happens. Okay, so for today's session, I think I'm good for this one. There is a couple of more here and there information I can share that offline. Just one thing, if you see one of that trace that I wanted to show, like right now, when we are trying to get that order history, basically we are putting it as an order ID, right? So that order ID needs to be there with each and every log that's available there, but not all the time that's the case. That is where trace ID comes into picture. So if you click on this order in here, we'll be seeing more information around it. So this is the trace ID that Newrelic creates automatically, and this Newrelic creates the trace ID, and this trace ID is propagated. Not all the, like, not all logs get this one. So just let me expand the time. So you see this trace ID is same across three logs in here. That we have this in here, we have this in here. But this trace ID means tracing that request from start to end. This was the starting point. But what about the other services that's there, right? That we were able to see with the order ID. Because those traces not got created in that one automatically. When we have this synchronous call this way, like service A calling to B and waiting for the response, that is why Newrelic is able to connect them automatically. So it assigns that a trace ID. But when there is a Kafka topic comes into picture, and then consumer comes into picture, it is not able to do that automatically, because we are not instrumenting the Kafka to the Newrelic, and it is not able to know that. So the consumer side logs we are seeing, but trace ID we are not seeing, but because it is a consumer, it is not the starting point of that one. It is not automatically doing that one, but there are way out to do that. So on the producer side itself, we have to add few lines of the code, and the consumer side also. That is how we will be able to trace the request start to end. I'll share that offline in a separate video maybe. But yeah, this thing that just wanted to spot. So yeah, this is it from my side on the tracing side and everything. If you guys want to share, like for the tracing and Neuralink, these are the things that you guys are using in your enterprise or something else.
So we are using ELK.
ELK, okay. ELK is, I think, ELK is all set up by the engineers itself, na?
No, I think DevOps setup will be there. So automatically take the same way for what you said. It's in the template will be there. It will be taken care automatically.
Yeah. And I meant to say that these Newrelic Dynatrace are the paid enterprise providers. ELK is something that it's set up within the company DevOps that does that one. So they don't
Uh,
pay
I'm
anyone.
not sure whether it's paid or not. I'm not sure. Sorry. Yeah.
So yeah, ELK stack, I think I know that that's the very good one actually. ELK is the it's stack logging basically. So Elastic as logging, Kibana. These are the three systems that can sit together
Yeah,
and
yeah.
push the
That
logs.
I understand. That I
Yeah.
understand, but I'm not sure whether it's paid or like individual.
So then like ELK is the stack, is this the infrastructure? It's not the like company anything as far as I know it is provided. It's the like different systems that can be put together to do the things that is needed for the tracing and observability.
Okay.
It does the same thing that we have Neuralink and all.
Actually, I have still the question with since we are doing today, it's like a event sourcing pattern, right? That's what we tried from the orders service, right? In a way, in architectural level, in this project, this order was going with the even sourcing pattern. If I understand, I have some questions. Maybe after this call, I will message you or something if I
Yeah,
want to understand further. Yeah.
yeah,
Thank,
sure. Just put the questions. We can connect offline for this session
yeah. Sure.
anytime
Sure.
after tomorrow.
Thank you.
Just wanted to know from others, like for the metrics, what you guys are using. Something for sure is there. Without that, debugging and everything is a nightmare. Okay, so anyway, so this marks the end of the sessions that we have, but still I'm open to discuss anything. This project, I will be putting that in the same repository. I'll suggest you guys to go through and see that. And around this project, anytime if you have any question, I'm open to discuss and make you understand if there is any confusion in any.
This project is more of like a summary of whatever till now we followed, right? So if we instead of doing every individual slab, if you do this project able to run local, then we'll be able to capture everything. Is that correct?
Correct. So
Thank you.
it has retry, DLT, that transactional configuration and all. So the enterprise level that we do, because in the learning these we understood a lot of things that is not needed actually, right? So we understood like Kafka template is able to send to the partition directly, the keying, ordering and everything. So all of that, whatever best out of that one is used in a transactional way or a Saga pattern that's there, it's implemented in this one.
Okay.
DLT retry and everything is there. So this is actually, we did not name it, but that's how the question is asked actually. What is a Saga pattern and how it is implemented? This is how it is happening. The architecture that I showed you, this is the Saga pattern. Event-driven architecture, that's we say.
Okay.
So we have, like I have shown you the happy path there, but feel free to set it up and try to do the any of the failure case and just see how it is reversing back the previous states that it was updated. I'll share this also like in some of the offline video. I'll share that.
Sure. Thank you.
Okay, thanks guys. And yeah, it was good time with you all.
One question. I read on your LinkedIn like you're supposed to start the part 2 of the series.
Yeah, let me stop this one. I can talk.